In the last video, we talked about base 10 number systems and how that's what we live in, but base 2 number system, the binary number system, is where computers live. But there's nothing special about base 2 or base 10. They were just uniquely useful to us at different junctures in our development as human beings. So here is a table where we have any other base number system. You could have a base 3 number system where we have 0, 1, and 2 as our digits, base 4 where we have 0, 1, 2, and 3 as our digits. And in every case, you just have the place values of the powers of that number. So if you're taking notes, take a minute and just fill out this table, so just to get used to the fact that a base 6-digit system will not have a 6 in it. It'll be from 0 to 6. It'll be from 0 to 5, and so on. So we have a few rules that we're going to have to remember. To convert from base 10 to another number system, we use the following rules. We set up place values for any base, call it b, and then keep writing the next value until it exceeds the number in question, and we'll talk about what that means. Divide your number by the highest place value, place the answer on the line, and repeat this step with your remainder until you have successfully reached b to the power of 0. Let's see what that means. So we want to convert 8 to base 5. So we have an 8, so let's set up a base 5 number system with powers of 5 until we pass 8. Powers of 5 are 0, or 5 to the 0, which is 1. I'll write it like this. 5 to the first power, which is 5. 5 to the second power, which is 25, and we can stop there because 25 is more than 8. So how many 5s are there in 8? Well, there's one 5 in 8. And then we do 8 minus 5, and we're left with 3. And then how many 1s are there left? There are 3 1s left. So 1, 3, base 8, or 13 base 8. That's not right. 1, 3, base 5, or 13 base 5, is the decimal number 8 in base 5. And now, since I keep saying things wrong, let's move on to the next one and see if we can get a groove going. So in the next one, we want base 8. We have 8 to the 0, which is 1. 8 to the first power, which is 8. 8 to the second power, which is 64. 8 to the third power, which is 512, and we're officially at a point where we're bigger than our number 299. So we know that our base 8, we don't need this one. In base 8, our number will be 3 digits long. And the first thing we have to do is figure out how many 64s there are in 299. So we have 299 divided by 64. And there are going to be 4 holes in there with some leftovers. So we're going to get a 4 here. And then what are the leftovers? Well, 64 times 4 is 256. 299 minus 256, well, that's an easy problem. There's no rounding. Is just going to be 43. And then we move on to our next place. We say, how many 8s are there going to be? Well, how many 8s are there in 43? There are 5 of them. 5 times 8 is 40. Subtract our 40. We're left with 3. We have a remainder of 3. And that is 299 in base 8. Moving on, converting 26 into base 2. We'll use blue this time. Well, 2 to the 0th power is 1. 2 to the first power is 2. 2 to the second, remember we're trying to see which number is going to be bigger than 26. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. And 2 to the fifth power is going to be 32, which is more than 26, so we'll stop here. Now let's see what 26 is in base 2. Well, we know there's 116 in 26. 26 minus 16 is going to be 10. We know there's 1 8 there. We know there's 1 8 there, so we'll subtract our 8 and we'll get 2. There are no zeros. I mean, there are no 4s in there, so we're going to have a 0 in that place. There is 1 2. And then when we subtract 2, we end up with 0, so there's none left. So 26 in binary is 11010. This is in base 2. And now take a minute and see if you can do 365 base 7 in base 7. If we want to do this, we have 7 to the 0th power is 1. 7 to the first power is 7. 7 to the second power is 49. 7 to the third power is 49 times 7, which is 343. And if I go one bigger, it's going to be way bigger than 365, so we'll stop there. So I see that I have 343 and 365, so I'll put a 1 and then I'll subtract. 365 minus 343 is going to be 22. 22 is smaller than 49, so we're going to have a 0 here. How many 7s are there in 22? There's 3 of them. Subtract 21 from here, or 3 times 7. We get 1, and we have 1 left. And that is converting from base 10 into another base.